Okay, today we are going to learn how to solve linear equations by graphing. And the linear equation that I'm talking about is when it is in the form of ax plus b equals cx plus d. Or an example would be x minus 2 equals negative 1/2 x plus 1. How in the world do we solve that? Okay, to start, we are going to take each side of the equation and turn it into its own linear equation. So what I mean by that is I'm going to take this left side here and I'm going to write an equation with it. Y equals x minus 2. So I just added y in front of it, y equals. And I'm also going to take the equation on the right hand side this one right here, and I'm going to write an equation with that one as well. Y equals negative 1/2 x plus 1. And then I would just take both of those equations, graph them, find the intersecting point, and that's my solution. Let's try it. Okay, my first equation has a y-intercept of negative 2, so I'm going to go down 2, and it has a slope of 1 or 1 over 1, so I am going to mark a dot at the y-intercept, which is right here. Oops. And I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. Keep going. Okay, now I'm going to attempt to draw a line between all the points. Great. That's pretty close. Alright, and my next equation has a y-intercept of positive 1 and a slope of negative 1/2. So I'm going to go down 1 and to the right 2, down 1 to the right 2, and I'm going to attempt again to draw a line. Okay, and I can already see that they intersect right at this point here, and that ordered pair is looking like 2, 0. So that is my solution. And if I plug it back into both equations, it should tell me that that is correct. And let's try another example together. I'm thinking 2x equals x minus 3. Okay, again, I'm going to take this side and write two separate equations. Y equals 2x and y equals x minus 3. Then on the next slide, I'm going to go ahead and plot them on a coordinate plane. Okay, the first equation is y equals 2x. There's no y-intercept, so I'm going to start at the origin, which is 0, 0. My slope is 2, or 2 over 1, so I'm going to go up 2 to the right 1, up 2 to the right 1. I'm going to go down 2 to the left 1, down 2 to the left 1. And I'm going to attempt to draw a line across all of the points. Let's try that again. Okay, The second equation is y equals x minus 3. It has a y-intercept of -3, so I'm going to go down 3, put a point, and a slope of 1, or 1 over 1. And I just wanted to extend that line a little bit further. And now I'm going to draw a line across these points. Try it again to get it a little more accurate. Okay, and I can see that they intersect. Let's see where they intersect. -1, 2, 3, -3, and -1, 2, 3, 4, 5, 6. -3, -6. Now, I'm going to erase this graph, and I'm going to plug that solution into both of my equations because I'm not positive that I am correct. I'm going to check my work. So I'm going to erase my graph very quickly. Okay. So my first equation is y equals 2x. I'm going to substitute -6 in for y equals 2 times -3. And I get -6 equals -6, which is correct. So far, so good. Now I'm going to try the other equation. And it is -6 equals x, -3 minus 3. And -6 equals -6. That is correct. So I know that my solution of -3, -6 is correct.